Okay, ladies and gentlemen, the question of the day is, who are Polymony, Biny, and Triny? And what do they have to do with advanced algebra? We're going to learn about that stuff. Our objectives are to identify, evaluate, add, and subtract polynomials. A big hint, okay? Classify polynomials by degree and number of terms, and describe the shape of their graphs. Okay? Does that sound like fun? It sounds like fun to me. So let's talk about some definitions. Sorry about that. First thing is monomial. The easiest way to describe a monomial is to show you one. That's a monomial. Okay. 18x squared y to the third z. That's a monomial. Okay. X plus 5, not a monomial. Why is that? Because you got a plus in the middle. 17 minus 3x, not a monomial. You got a minus in the middle. So if you're separating by a plus or minus sign, you don't have a monomial. It doesn't matter how many numbers or variables are in the monomial. If it doesn't have any plus or minus signs, it's a monomial. You say, well, wait a minute. So this isn't a monomial? No, this is a monomial also, because it doesn't have any other monomial or any other terms there. So even though it has a minus sign, it still is only one term. And then, what about this thing? 17. Is that a monomial? Yes, it is a monomial, because this is like 17 times x to the 0 power, isn't it? Because x to the 0 power is equal to 1. So 17 times 1. Anyway, it's still a monomial, okay? I mean, actually, this is a special kind of monomial. It's called a constant. For example, you know, if we have y1 equals 17, well, what is that? That's a horizontal line at y equals 17. So it's a constant. A constant function is just a horizontal line. Okay, so what does all this mean? Well, what is a coefficient? Change colors. Notification, change of colors. Coefficient it's the number in front of the variable. Easiest way to describe it, the number in front of the variable. Example, x, what's your coefficient? 1, right? Negative 2t, what's your coefficient? Negative 2, of course. Remember, you have to have the sign with it. Negative x to the third y squared over 3. Now, this is a tricky one. What's your coefficient? Negative 1/3. Well, why is that? Because you can say negative 1/3 times x to the third y squared is equal to negative x to the third y squared over 3. So that's why negative 1/3 is your coefficient. Okay. What about negative AB? What is your coefficient? Negative 1, of course. So this is a coefficient. That's the number in front of a variable, or if you can rewrite it in such a way that you have a number like this in front of the variable or variables, that's the way it is. But wait, there's more. New color, new color. Degree. Now this is an important distinction. Degree of a monomial, again, this is easiest to show you. Basically, you add all exponents, and don't forget to add the 1. For example, you have x squared y z. This is a monomial. What's the degree of the monomial? You got 2 and you got 1 and 1. Even though we don't show the 1, that's how many. So the degree is 4. Okay? Try another one. WZ squared. the degree is 1 plus 2 is 3. Okay? And even more, let's say 7 x to the 5th, y to the 2nd, z. And what is your degree? 5, 6, 7, 8. Okay? That's what the degree of a monomial is. And finally, now that we've said all that, let's get to the real thing. What is a polynomial? Well, a polynomial is a monomial. Yes, a monomial is considered, even though poly means many, we still can include monomial in the category of polynomials. A monomial, a binomial, or a trinomial, and etc. Because you keep going up and up and up. It's just that after a trinomial, we don't usually call them, like if it's 4 terms, we don't usually say quadrinomials. It gets too complicated. So that's what a polynomial is. Monomial, binomial, trinomial, etc. What does that mean? That means 1 term, 2 terms, 3 terms, or more terms. Okay? The degree, and let's change color again and move this thing up a little bit. Okay? Polynomial. The degree of a polynomial. Now remember, I said the degree of a monomial is when you add all the terms. Degree of a polynomial is different. It's just the degree of the highest or largest exponent. Okay? And I'm going to show you a couple examples in a minute here, okay? But just degree is the highest exponent, and the standard form of a polynomial okay, the highest degree to the smallest or lowest degree. Okay. For example, let me show you what I'm talking about. We got, and I'm going to move this down because I got a couple of them that I've got to write here. All right. Let's try the constant, or excuse me, the let's try. Okay. Degree. I'm going to show you a bunch of polynomials with different degrees and. Okay, so let's talk about first of all a constant. Okay. Okay. Example would be like 5. Okay, that's a constant. The degree is 0. Okay, because that's like 5 times x to the 0 power. So your degree is 0. Okay. Linear. Okay. A linear function or linear equation. It has degree 1. An example would be 3x minus 5. Okay? Simple linear function. You know, you know what I'm talking about. Quadratic. What do you think? The degree is 2, of course. And we're talking about like 4x squared minus 5x plus 11. Cubic. Degree is 3. And we're talking about like negative 3x to the 3rd plus 4x squared minus x plus 4. Okay. And quartic, degree 4, would be something like x to the 4th plus 2x to the 3rd minus 11x squared plus 5x minus 2. And finally, quintic, and I say finally, it goes higher than this, but we're not going to worry about that right now. Negative 2x to the 5th plus 7x to the 4th minus 5x to the 3rd minus 12x squared plus x minus 1. Notice in each one of these examples, I start with the highest degree and move down to the lowest degree. These are all written in standard form, okay? These are all written in standard form. You start with the highest degree and work your way down to the lowest degree. You will see me doing that on a regular basis. And I want to emphasize, you're very seldom, or half the time, you're not going to get your polynomials given to you in standard form. So, let's see what else we have going on here. Okay, classify. By degree and number of terms. By the way, that hashtag, traditionally that means number, so I write that instead of number. So let's say 2x to the third minus 3x plus 4x to the fifth. Now what's the degree? Well, you see 3, 1, and 5. So the degree is 5. That's the number of the highest exponent. Okay? How many terms do you have? 3. So it makes it a trinomial. So you have a quintic, because it's degree 5, trinomial. Quintic trinomial. Okay? Now, if the degree were 6, you don't have a term for 6. Okay? You say that a trinomial in the 6th degree, or 6th degree trinomial is what you would say. Okay? What about 7x squared minus 2x to the third plus 3x to the fourth? Aha! 4th degree, so it's a quartic, and it is also a trinomial. Okay, so that's real simple. Now, let's try evaluating. Evaluate means to plug in a value for x. So evaluate 3x to the fourth plus 2x squared plus 2x minus 5 for, first of all, x equals 1.5, and secondly, x equals 2.5. Now, I'm going to show you a real quick and easy trick on your graphing calculator, which makes this so simple. Okay, here's what you do. You turn it on first, like that, okay? And you do this. You say 1.5, store. That's this little button in the lower left, right above the on button. Store, it gives you an arrow, as x. And then enter. Very important, you have to hit enter. So there's 1.5. So now you say 3x to the fourth plus 2x squared plus 2x minus 5. And watch what happens. There is your value. Okay? And let me get that back. 17.6875. And so what do you do if you want to do this for x equals, well, you go 2.5, store as x, enter, and what about, you have to type all that stuff back in again? Nope, just second enter, and there it is again, enter, and now it's 128, or 129.6875. So it's 129.6875. So anytime you got remember, anytime you have a polynomial like that. Now, of course, the other way to do that would be to graph it or plug it into here, okay? But we're not going to do that right now because time. I'm trying to be brief on this stuff. We also have to try to find how to add and subtract polynomials, okay? So, add. Negative 2x squared minus 3x to the third plus 5x plus 4, okay, plus negative 2x to the third plus 7x minus 6. And how do you do that? Well, it's pretty simple. You look at for the biggest degree, 3 and 3, okay? You got negative 3x and negative 2x. So that's a negative 5x to the third. Negative 3 and negative 2 make negative 5. Okay? So those are gone. And then negative 2x squared, and there's no more x squared terms. So negative 2x squared. Okay? And then 5x and 7x is plus 12x. Okay, those are gone. And then 4 and negative 6 is negative 2. And so there you are. That's it. So what do we try? Subtract. This is a little trickier, obviously. And this is why. Negative 6x to the third minus 6x squared plus 7x minus 1. Oops, it looks a little funky there. Okay, minus 1 minus, okay, 3x to the third minus 5x squared minus 2x plus 8. Now, I'll tell you what. I'm going to show you the way that I think will help you the most right now, okay? And that is to rewrite everything as individual terms and then combine like terms. And this is what I mean. Negative 6x to the third, negative 6x squared, plus 7x minus 1. Now I'm going to distribute this to all these. And the reason I'm telling you this, folks, I cannot emphasize this enough. This is the biggest mistake kids make when you're learning this stuff. So negative 3x to the third. Negative 5x squared. That's a positive 5x squared. Negative 2x. Positive 2x. Negative positive 8. Negative 8. Now I can just combine like terms. I got negative 6x third, negative 3x to the third is negative 9x to the third. All right. Negative 6x squared plus 5x squared. Negative x squared. Negative 1x squared is negative x squared. 7x and 2x plus 9x. And yes, you need some practice with this. And negative 1 and negative 8 is negative 9. And so that is the result. Okay? And very, very important. And now there's one more thing I've got to show you, and then we'll be wrapped up. I know this is kind of long. All right. Let me show you something. This is the graph of a quadratic function, okay? And we had a whole chapter about this, okay? F of x equals x squared plus x minus 2. The way you describe this graph is you would say it's a U-shaped graph, okay, with one U-turn. You see, it makes one U-turn, and it's a U-shaped graph. So that's how you would describe that. And I would write that down, but I'm trying to be quick. Okay? Let's look at g of x. G of x is a third degree. Okay? Notice now, this is a S-shaped graph. Okay? It's an S-shaped graph. And look, there are two U-turns. You see it comes up from here, reverses direction, comes down here, reverses direction, and goes up there. Okay? And then h of x is a fourth degree. And take a look at how this thing works. And I'm going to try to move this up a little bit so you can see you see this? This is like a W shape, isn't it? Okay? So it's like a W shape, and it's got 1, 2, 3 U-turns. Okay? So 3 U-turns. Did I say that this has 3 U-turns? No. This has 1, 2 U-turns. Okay? I don't remember what I said about it. But this one has 3 U-turns. Okay? So that's how that works. That's all I have for you. Thanks for hanging in there. Bye.